Welcome to the slop farm. Enjoy the video.
You start by preparing your instruments and environment. Place the compass or magnetometer level on a non-magnetic surface and keep electronics at least 1 meter away to avoid interference. Once done, take an initial reading of magnetic field strength and heading. Note both values. You must also record the time and any nearby ferrous objects. This first measurement gives you the local magnetic bearing and magnitude, which you'll use to calculate the current direction relative to true north. You now convert the magnetic reading into a true heading. First, obtain the local magnetic declination. This is degrees east or west of true north. If declination is east, add it to your magnetic heading. If west, subtract it. For magnetometer vectors, rotate the vector by the declination angle and recompute the azimuth from components using Aten-2. Make sure to apply consistent sign conventions. This yields the true heading and ensures your direction aligns with geographic coordinates. You finish by verifying and finalizing the direction. Cross-check your true heading against a GPS course or a map bearing to confirm accuracy. If you require 3D direction, correct for magnetic inclination to get the true vector in 3 axes. Once done, average multiple measurements to reduce noise. If readings fluctuate or seem off, move 2 to 3 meters away from possible interference and remeasure. That single troubleshooting step usually resolves inconsistent magnetic reading.
Thanks for watching. Consider subscribing if we helped you today.